Okay, it's time for some average velocity questions. Average velocity is the change in displacement over the change in time. And displacement being something called a vector. A vector has a direction, and you would have worked on displacement yesterday. That's what velocity is. It looks like this. It's got a little arrow above it, and it's equal to the change in displacement over time. Time doesn't have a vector because time only goes one way. Remember, vectors have both direction and magnitude. Oh yeah, just like Vector from Despicable Me. Okay, so let's try a problem. We'll start with some easy ones. Here we have an antelope traveling north, and it travels in a certain amount of time. What is velocity? Well, let's write down our formula. Velocity is change in displacement over time. There is our displacement because it's got a direction. 13.5 kilometers north over the time, that's our time, 0.30 hours. That's a weird looking zero. 0.30 hours. Okay, 13.5 divided by 0.3 gives me 45 kilometers per hour. What did I forget? Oh yeah, the direction. Okay, so that's pretty simple. Just plug and chug. Putting the numbers into the formula. All right, this next one's a little bit trickier. It says an object has a displacement from its original position of 0.55 meters. So that positive is a direction. It's moving positively. That is our displacement. And it gives us a velocity. What is the time? Okay, so let's write down our formula. Velocity is displacement over time. Now, if you remember in the previous video when we were looking at speed, if we're solving for time, we can do a little switcheroo here. The time comes off the bottom, and we get time is equal to displacement over velocity. We can plug our numbers in there now. 0.55 meters over positive 1.3 meters per second. So when I divide that out, I get 0.42 seconds because time is measured in seconds. How did I know time was measured in seconds? Well, the only time variable is the second. Just like up here, it was kilometers per hour because we had a time in hours. All right, I'm going to go a little slower on this question. This is a fun question for those of you guys who used to play Grand Theft Auto. Maybe you still do. Trevor Phillips carjacks a Pontiac Solstice and drives it 45.6 meters out into the desert due east. Now, we could draw a picture of this because it looks like we're going to be moving different directions. So I'm just going to start that. We got west is going this way, east is going this way, and he moves 45.6 meters that way. This takes 100 seconds. Okay. For the heck of it, he drives back to town. 15.5 meters from his point in the desert, his car breaks down. So that sounds like he's going back west, 15.5 meters. And the second drive took 3.2 seconds. So that's a little picture. Velocity uses displacement. So we have to figure out where Trevor is from the start. So if we said east is positive and west is negative, when we subtract the two distances, we get a total of 29.5 meters. I'm subtracting this because that's the distance Trevor is from the start point. Right there, 29.5. Now, which direction is he from the start? Well, he's still east. The time we have to add together. Trevor drove for 100 seconds, turned around, and came back for 3.2 seconds. So we're going to add both of those times together and get 103.2 seconds. Now we have both displacement and time. You could also just decide to go, all right, I've got 45.6 meters, and I'm going to subtract that from 15.5 because subtraction means I'm going the opposite direction. You don't need the little picture if that doesn't help you. So 29.5 divided by 103.2, we get a fairly small number. When I divide all that out, I get 0.28. Let's round it 6, the 3 digits, 286. And my units are a meter on top and a second on the bottom. And which direction am I going? Oh yeah, east. All right, last question. Devin hops on Braden's dirt bike and drives with him to the store, which is 345 meters from Thurber. So he's going west. They see Mr. Zed walking and decide to go and make fun of him, because that's what you would do. Why am I walking that way? Who knows? They drive 130 meters east towards Mr. Zed. Braden forgets he needs some pudding pops at the store, so they drive back, but the dirt bike breaks down. They only travel 90 meters west. So this whole debacle took 15.2 minutes. What is the velocity of the trip? Okay, so we've got to break down the direction that Devin and Braden went. So let's say west is positive, 345 meters. And then we're going the opposite direction, which is east, 130 meters. So I'm going to subtract it. Okay. Then I went west again. What would I do to west? Would I subtract or add? Well, because this is positive, I'm going to add 90. So I'm subtracting the east from the west to get the overall distance. So 345 subtract 130 plus 90 gives me a total displacement of 305 meters. Now, which direction is this? If T is Thurber, it looks like they went west. They came back to make fun of me, forgot they needed pudding pops, and their car broke down. So they're about here, right? Like if you think of this as 345, that's 130 going the other way, and then they're going this way is 90. They're west of the start. Okay, so that's my displacement, 305 meters west. Now, the time is given to me in minutes. That's a bit of a problem. What should the time probably be turned into? If you said seconds, you were right. If you said hours, you're a crazy person. So in order to turn minutes into seconds, I got to times that by 60 because there are 60 seconds in a minute. So I get 912 seconds. Wow, perfect. 305 divided by 912 gives me 0.334 meters per second. What did I forget? The direction. Oh, yeah! Oh, yeah. Okay, so velocity. Whoa. Velocity. Velocity has direction. And what we covered a couple days ago was speed. It does not. So today, you're going to work on some velocity problems, and then you're going to have a worksheet which has a whole bunch of stuff put together. The worksheet is going to have both velocity and speed. So just today, we're working on velocity. I dropped the pen, and that's it.